Welcome to this video. It's previous the tutor. In chemistry, we are going to focus on rates of chemical reaction. Now, examiners, all right? Examiners love this question, all right? And most students lose marks because they don't explain it right. Now, I'm going to explain this one in simpler terms, all right? So, the rate of a chemical reaction is just simply how fast reactions turn into products. Are we there, right? It's how fast reactants turn into product. But here's a secret. Let's say you double the concentration of the acid, right? The reaction can more than double actually in speed. Why do you think? Because when you double the concentration, you increase the number of particles per volume, meaning more collisions per second, and boom, a faster reaction. That is what is behind chemical rates of chemical reaction. All right. So what is this? I've already explained what this one is. It is the speed at which reactants are converted into products per unit time. All right. So a rate of chemical reaction is the speed at which reactants are converted, all right, into products per unit time. Yes. And like I said, it is just how fast these reactants are turned into products. Are we there? Now, for this process to occur, it is accompanied by what we call the factors. Now, these factors can affect the rate of chemical reaction in a negative way or in a positive way. Therefore, if you are explaining how a certain factor affects the rate of chemical reaction, you have to explain in two ways, the negative and the positive. All right? So let's look at the factors. Before I even go to the factors, if I have got product A reactant A and B reacting together to form C and D, these are the products. Meaning I can find my rate, all right, based on how A is decreasing, concentration, for example, in terms of time, or how B is decreasing. I'm showing a negative sign to say it is decreasing. So change there. Or I can denote by, since C is being formed, it means the concentration of C is increasing. Or I can say the rate at which concentration of D is increasing. You've seen, right? I can use any of that to measure the rate of chemical reaction. Remember, we are saying per unit time, so time should be there. The negative meaning the concentration of the reactant is decreasing. Positive means the concentration of the product is increasing. So now, what are the factors, okay, that affect the rate of chemical reaction? Okay? What are these factors that affect the rate of a chemical reaction? Number one, all right, temperature. So I'm going to put factor here. I'm going to put positive and negative. Positive and negative there. Or let me say high and low. Okay. I think this one is better, right? So the first factor is temperature. So when temperature is high, what happens to the rate of chemical reaction? Rate increases. Okay? Reason is simple. The rate increases. Okay? Why? Because particles gain kinetic energy. All right? Particles gain kinetic energy. All right? Meaning there is more more collision. Hence increasing the speed. The reaction rate. Are we together? Ka? When temperature is low, what are we saying? Particles do what? Lose kinetic energy. If particles lose kinetic energy, meaning there's less collision between the particles, right? Meaning decreasing the rate of reaction. So don't just explain that, no, a high temperature increases the... well, I'll mark you wrong myself. Explain how exactly that happens, all right? Kinetic energy must be mentioned, collisions must be mentioned, and how the rate is being increased. Next is concentration. So what happens when concentration is high? Meaning, when you increase the concentration, meaning more particles. Are we together? More particles. More particles result in more collision. More collision. Because of more collision, what happens? Rate increases. When concentration is low, there are fewer particles, so lesser particles. Meaning there is less effective collision. Okay? Meaning rate decreases. Have you seen how I'm explaining? There are 3 points on each part. All right? I'm not just saying decreases, increases, what and what. No. Okay? Next is the surface area. All right? Now, for surface area, here is what you need to know. The smaller the particles, right? Meaning they are a lot in number. All right? So this one, smaller particles, meaning more particles. All right? If the particles are smaller in size, meaning there are more of them, meaning more collision, meaning rate increases. A large surface area means larger particles, meaning there are fewer particles because they are large. Because of this, there's less collision and the rate decreases. Next is catalyst. Now, on the catalyst, I want to explain and make this clear. A catalyst only provides an alternative path. What is low is high, no. So for the catalyst, we are taking at the whole part here. What it is low, it is high, no. So for the catalyst, it only provides, right, an alternative path of reaction. Because of this, more particles resulting in more collision. Right? It lowers the activation energy. What is the activation energy? It is the energy required for a chemical reaction to start. Let me draw up an energy profile diagram, all right? Let's say you have an energy profile diagram of this nature, all right? So, you discover that here you've got A plus B, and here you've got C plus D. You can clearly see that the energy required by the particles A and B is what we are calling activation energy. That energy is needed by the particles no matter what. That is what we are calling activation energy. All right? Then we have what we call the change, all right, in the heat of reaction. That was what we're calling delta H, known as enthalpy. Okay? It is a change in the amount of heat between the products and the reactants. Is it making sense, huh? So now, for the catalyst, a catalyst will come and say, I'm going to provide you a lower activation energy. Have you seen from there to there? This is lower than that one. Meaning, if a catalyst lowers the activation energy, it means you have more particles, more collision, and hence the rate of reaction does what? Increases automatically. That's what a catalyst does. We also have the issue of pressure. Now, pressure only affects gaseous reactions. These are reactions where gases are only involved. For example, if I get nitrogen and hydrogen, these two, all right, they are going to give me ammonia. All these are gases, meaning pressure can affect this reaction. More pressure, more collisions, meaning the particles have more energy, hence the reaction is faster. Less pressure, meaning the particles do not have enough energy to collide, meaning there's less collision. If there's less collision, meaning the reaction rate does what? Decreases. All right? Now, all these, I think you've seen me, I've been mentioning collision. What is this collision? This collision is actually attributed to the collision theory. Attributed to the what? Collision theory. Meaning, what is the collision theory? Well, the collision theory is a theory that states that for a chemical reaction to take place properly, two particles must what? Be in a good position. Now, what is this position? This position is what we are calling a correct orientation. Is it making sense? Correct what? Orientation. So, for a reaction to occur, it says for a reaction to occur, all right, number one, particles must collide. Particles must what? Collide. Next, collisions must have enough energy. Collisions must have enough energy. This energy is what we're calling the activation energy. All right. Number three, particles must be in the correct orientation. Are we there, right? Exactly. Now, ladies and gentlemen, if this makes sense to you, imagine what you will achieve with my full exam preparation classes. Let's turn these tricky topics into easy marks, all right? I'm just giving you something on the surface. Are you going to join my online classes, or you are going to wait for another free lesson, which is also incomplete? There are a lot of things here. There are graphs. There are what? Calculations of rate from the graph. Are you sure you want to miss those things? My number is there. WhatsApp me, all right? PVS the tutor. I'll be able to help you. Remember, it's not free.